Okay, so here we will have a short lecture on the propagation of error. Our main reference is our textbook, Turner. So our flow for our discussion is first is to discuss a general function Q with variables x1, x2, and so on until xn. And then we will discuss the variance a sum of sums for a generalized function Q, that is a sum of variables x1, x2, and so on. And then we'll discuss briefly the variance of a product of multiple functions to arrive at the general function Q. And then we'll apply it directly to two common examples, uh, some equations in general physics. So, yan yung flow ng discussion natin dito. So, let's consider a generalized function Q, which is a function of multiple variables x1, x2, and so on until x sub n. Note that the variables x1, x2, and so on until x sub n are independent of each other, with each variables having mean mu sub I and variance sigma squared sub I. Note that I here represents an index variable ranging from 1 to n, where n is the number of variables in your generalized function Q. So we perform first order power expansion. This is yung standard na Taylor expansion ninyo. So I hope na nalala pa yung Taylor expansion. Since this is first order, yung exponent natin dito, x sub I minus mu sub I, yung function natin, ang power nitong term na ito ay to the first power since first order power expansion lang ginawa natin. And note that the quantity mu, here yung bold mu dito, is a vector. So, ganito yung itsura ng mu natin. So, mu sub 1, mu sub 2, mu sub 3, and so on until mu sub n. So, you evaluate the first order derivative with respect to the variable x sub I at the various means of your variables. Okay, so this is your first order series expansion. We only expanded your first order series expansion since we have this notion that your variable x sub I is close to your means mu sub I, and higher order expansions are very small in comparison to your first order expansion of your generalized function Q. We now proceed to calculate the expectation value of your generalized function Q. So first, what is the expectation value of your generalized function Q as a function of your variables x sub I? So note that if we take the expectation value of this quantity, of this whole thing, for your second term, evaluate natin yung expectation value nito. This is a constant. If we evaluate the expectation of value of x sub I minus mu sub I, note that the expectation value of x sub I is equal to mu sub I. For your variable x sub I. So if we take the expectation value of the whole thing, the second term will have a zero value, since the expectation value of xi minus mu sub I is equal to mu I minus mu I, or this is equal to 0. Note that again, ulitin natin to, the expectation value of your variable x sub I is equal to mu I, and obviously if you have multiple iterations or number of trials for your constant mu sub I, kahit ilang beses mong ulit-ulitin yan, ang lalabas ay mu sub I pa rin. So, mag-cancel yan. Yung expectation value ng x sub I minus mu sub I will be 0. So, ibig sabihin, class, yung second term, do sa first order power expansion natin, magdi-disappear if we take the expectation value of the whole thing. So, the expectation value of your function q sub x sub I is given by q as a function of your mu. Take note again, this mu is a vector. So, this is given by your vector mu1, mu2, and so on until mu sub n. Okay, so now we proceed to evaluate the variance of your generalized function q. So we use this first order approximation. So we now have this expression. So the expectation value of q x sub I. So this is equivalent to q of mu plus the summation of I from 1 to n of partial of q xi evaluated at mu, yung vector mu, xi minus mu minus q mu this whole thing squared. So this is now your variance. Okay, take note na mawala yung q sub mu. Ang matitira na lang na term is yung summation term, and then we square it, and then we take the expectation value, and then we arrive now at the variance of your q of x of i's. Okay, proceeding our calculation. So we now have this. So summation of I from 1 to n of partial of q with respect to x sub I, x sub I minus mu quantity squared, and the expectation value of this whole thing. Kukunin natin yung expectation value ng buong yan. So let's first expand this series. Series. Okay, so this is equivalent to. Okay, pansinin nyo, meron tayo mga i's. So partial with respect to x sub 1. Spell out muna natin yung first few terms para clear tayo. So meron tayong partial of q with respect to 1 times x sub 1 minus mu sub 1, tama, plus partial of q with respect to x2 times x sub 2 minus mu 2, plus and so on, plus partial of q x n x sub n minus mu sub n, and then this whole thing is square natin. Okay, take note, we squared this whole thing, and then later on we evaluate the expectation value of this whole thing. Okay, so obviously magkakaroon tayo ng mga powers of 1 na term. So meron kang x, since in-square natin yung buong ito, meron kang partial q x1 squared times x1 minus mu1 squared, and then partial of q over with respect to x2 times x2 minus mu2 quantity squared, and so on. At meron din tayong cross terms. So yung cross terms natin is yung x1 times x1 minus mu1 times partial q x2 times x2 minus mu2, and so on. So marami tayong cross terms. So in general, in summation form, we now have yung square nitong buong ito, and then later on we get the expectation value. This is given by yung ano lang, yung mga perfect squares muna. So sum of I from 1 to n of partial q with respect to x1 squared times x1 x sub I minus mu sub I. Gawin na nating sub I squared. So ito yung mga perfect squares. Plus yung cross terms. I not equal to j. So dalawa yung may index, may ano tayo, may multiple index tayo. So we have partial q, partial xi, partial q, partial xj times x sub I minus mu j times x sub I minus mu sub I and then you have x sub j minus mu sub j. So take note, you're evaluating it at your mean vector mu. Okay, so you now have this expansion. So yan, so far. Now, if you evaluate the expectation value ng buong to, okay, class, pag in-evaluate mo expectation ng buong to, this term, itong terms natin na ito, they will cancel each other out. So for 1, yung xi minus mu I, pag kinuha mo yung expectation value noon, it will be 0. Yung tulad nung diniscuss natin kanina, yung expectation value ng xi minus mu I, that is equivalent to 0. And another thing, so if we consider this thing, expectation value of xi minus mu I times the xj minus mu j, we also assumed earlier na yung variables natin na x, they are independent from each other. So if we assume that they are independent from each other, therefore hindi sila correlated with each other. So yung expectation value ng product nila is equal to 0 kasi hindi sila correlated sa isa't isa. Okay, so continuing, our variance now, yung sa previous slide, is given by this equation. So variance of q of x sub I is equal to the expectation of the summation of I from 1 to n of partial of q with respect to x sub I squared evaluated at mu, yung expectation ng buong yan, times x sub I minus mu sub I quantity squared. Okay, so yung e, pwede natin ipasok sa part na ito, sa loob, dito. Ito kasi constant naman ito eh. So meron kang summation ng expectation value ng x sub I minus mu sub I squared. Okay, so let's review, class. So expectation value ng x sub I minus mu sub I squared. Let's expand this. So this is equivalent to your expectation value of x sub I squared minus 2x mu 1 mu sub I plus mu sub I squared. So, expectation value ng natin is given by this. Expectation value ng xi squared minus 2 expectation value ng xi mu sub I plus mu I squared. So this is equivalent to expectation value of xi squared. Ito, expectation value ng xi is mu sub I. So this is given by minus 2 mu sub I squared plus mu sub I squared. So minus mu sub I squared, or this is equivalent to your expectation value of x sub I squared minus, take note, mu sub I is your expectation value of xi. So this is given by expectation value of xi quantity squared. Ang tawag natin dito is variance. So we have discussed this earlier in our term. So this is the variance of x sub I, itong term na ito. So yung term na ito, yung expectation value ng buong term na ito is given by your variance. So you will arrive at this variance of your generalized function q sub x sub I as the summation of the partial of q with respect to x sub I squared multiplied by the accompanying variance related to your x sub I and your derivative partial of x with respect to partial of xi is evaluated at your mean mu. Again, this mu is has multiple values. So yung mean natin ay tandaan natin ay vector. So mu 1, mu 2, and so on until mu sub n. Okay, so yan yung estimation natin ng variance. Now, once we have estimated the variance, as discussed in the previous lesson, in lecture 7, pwede na tayo magkaroon ng plus minus o yung interval estimation. So take note na pag meron tayong variance, let's say meron tayong associated statistic which is your z-score. So meron kang z-score. So meron kang kung naalala pa, meron kang negative z alpha over 2 less than something, yung z-score nung kung ano man yung variable na gusto mong tingnan. So let's say mean of q sub x o q sub mu. Okay, q sub mu minus, let's say, your estimator. So q hat as a function of, let's say, your estimators. So let's say lagyan lang natin ng x hat all over yung variance mo, var of q all over sum n, parang ganyan, is less than z alpha 2. So your once you have the variance of your function, pwede ka na mag-create ng estimates of your confidence interval. Okay, so for the sum and difference, let's write things once again. So we have your variance of q is given by the summation of I equals 1 to n of your partial of q with respect to x sub I squared times sigma sub I squared. So kung yung function mo ay a sub I times x sub I yung kanyang form, ano yung ibig sabihin nito? Yung partial derivative ng q with respect to x sub I is given by a sub I, and then you square it. So you essentially have a sub I squared times sigma sub I squared. So it can be easily derived. Another a consequence of this formulation is that we can now formally derive the variance of your mean. So take note, for the calculation of the mean of your sample mean, we have this function q x sub 1, x2, and so on until x sub n is equal to x1 over n plus x2 over n plus x3 over n plus and so on plus x sub n over n. So yan yung process natin. So it's also emphasized that your distributions and then likelihood of x1, x2, variables x3 and until xn and so on have a distribution with mean mu and variance sigma sub I squared. And since pare-parehas yung process dun sa pagkuha ng yung sa averaging yung random values na lumalabas sa x1, x2, x3 until xn and so on, equal yung mga variance na yan, yung sigma 1 squared is equal to sigma 2 squared is equal to sigma 3 squared and so on. For this particular samples x1, x2, x3 and so on. So pare-parehas yan. So if we use this formula, yung formula na yan, ano yung mangyayari? So we ang a sub I natin is given by 1 over n. So meron kang 1 over n squared sigma squared, since pare-parehas naman yung value nung isa, and then you multiply it n times, so meron kang sigma squared all over n. So ito yung variance ngayon nung iyong sample mean. So we have now derived it. So initially tinanggap lang natin to yung variance na ganyan. So yung ginagamit natin na pag-estimate ng mu, yung estimator natin ng mu, which is given by the confidence interval negative x bar minus z alpha over 2 sigma over square root of n towards until x bar plus z alpha over 2 sigma square root of n. Yung term na to, yung parang standard deviation natin, ito yung dinerive natin kani-kanina lang. Okay, so I hope this is clear. For your product and power, so you have this formulation q of x sub 1, x sub 2 and so on until x sub n. If it's a product of x sub 1 to the p, may power kang p, x sub 2 to the p, and so on until x sub n to the p sub n. So nasa Turner naman yung derivation nito. So your variance q is given by q squared evaluated at mu is times the summation of your exponents p sub I times the variance sigma sub I squared, standard deviation associated with the population sigma sub I over mu sub I, yung whole thing squared. So yan yung formula for the variance of Q. However, class, meron tayong formula din sa exponential. Para sa akin, enough na yung formulation na ito. Mas malayo yung mararating nyo if you just remember this specific formulation. So actually, no need to remember yung sum, tsaka yung product and power, tsaka yung nasa Turner na exponential. Okay, enough na tong ano na to, yung variance of Q. as summation of yung first order derivative with respect to your variable squared times yung iyong variance at that specific variable. Okay, so we now apply the calculation of your variance at some standard physics formula. So in this case, you have your speed, which is given by distance over time. So given that yung distance d has variance sigma squared d, and your time t has variance sigma squared sub t, assume that you have measured d and t. So na-measure nyo na yung d and t. Usually, itong variance na ito is associated to the uncertainty of your measuring material. And then, yung measured D and T, siya yung parang expectation value. So, ito yung na-measure mo, yung D at saka yung T. Pero meron kang uncertainty which is associated with your variance. So, kung gusto mong 95% confident yung measurement mo, so you are estimating your measure D with a central value of D, and then yung meron kang confidence interval. So kung alam mo yung variance, in which case in this case alam mo, so parang yung kanina D minus Z alpha over 2 sigma D over square root of n kung ilang measurements yung meron ka, until D plus Z alpha over 2 sigma D over square root of n. So yan. So you can construct your confidence intervals. So ang goal natin dito is given na alam mo yung variance ng distance at variance ng time, at alam mo yung expected measured values ng distance and time, you can express your calculated speed S as a function of your distance and time, and yung corresponding variances ng kanyang distance and times. So you'd express yung variance ng speed as a function of D, T, sigma squared D sub D, and sigma squared T. Okay, yan yung gagawin natin in this slide. So recall, so your variance of Q is given by summation of I from 1 to n of partial of Q with respect to x sub I squared sigma sub I squared. So in this case, yung variance ng speed natin, speed is equal to the summation of tanggalin natin yung summation, dalawa lang naman yung variables. So this is equivalent to partial of speed with respect to time squared evaluated at your mean. So given yung mean natin, mu sub d evaluated at d and t, tama? Ito yung measured natin na mean, expected measurement natin, d and t, times sigma squared t plus partial of s with respect to kung t tapos na tayo sa t, d squared evaluated at d and t, yung mean natin, and multiplied by the variance of sigma squared d. Okay, take note, s is equal to d over t, partial of s with respect to t is equal to negative d over t squared, then partial of s with respect to d is equal to 1 over t. Okay, so hence, madali na to class. yung i-substitute naman natin sa function natin is yung mean, yung expected measured value natin, yung central value natin na d and t. So we now have partial of s with respect to t. So d over t squared sigma squared t plus 1 over t squared sigma squared d. And then this quantity is equivalent to 1 over t squared. So yan na class. Ito na yung variance ng speed as a function of d, t, sigma t, and sigma d. So let's check the units. Ang speed natin, ang variance, since speed yan, squared. Nasa squared, it's a squared quantity. So that's meters per second. So since variance to, ang dimension niyan ay meters squared second squared. Okay, so tama ba? So meters squared second squared. So pag tinignan natin yung first variable, yung first expression natin, yung d natin squared, meters squared, ito t to the fourth times sigma squared. So same, so d squared over t squared yung magnitude ng first term. Yung second term, variance natin, distance squared all over t squared. So consistent yung dimension. So ito yung expression for your error. So you can also express this as a function of s. So pwede nyo manipulate yan as a function of your variable s. So in this case, d over t is equal to s. Pero enough na yan for our discussion. Yan na yung variance ng speed measurement. So okay, and then another example is your voltage, which is equal to current times resistance. So take note that this is a product. So again, no need to memorize yung product and potential and then yung exponential sa Turner na book. Ang i-memorize lang yung variance of Q is equal to the summation of partial of Q with respect to x sub I squared sigma I squared. So if you are trying to estimate your voltage, so yung variance ng voltage natin, so yung variance ng voltage natin is given by partial of V with respect to I squared times sigma I squared plus partial of V with respect to R squared sigma R squared. Okay, so note V equals IR. So partial of V with respect to I is equal to R, and partial of V with respect to R is equal to I. So this is equivalent to R squared sigma squared sub I plus I squared sigma squared R. Okay, so ito yung variance ng voltage natin. Okay, consistent naman yung parameters natin, yung dimensions, because sigma I, ang units ng spread ay current squared. So current squared times R squared. IR is voltage, IR squared is voltage squared, which is yung dimensions ng variance. So yan, ito na yung expression for Ohm's law na variance ng voltage. Okay, once again, once you have calculated the variance for your function V, you can now formally create yung estimates for your interval or yung confidence interval mo. So thank you very much. So meron kayong group assignment na regarding here. So meron kayong 4 functions, and then you are to derive the variances of those 4 functions based on variables associated with that specific function. Okay, thank you very much.